Yes, this is the 3B problem set. Let's take a look at the first two problems. See if we can figure these out. Calculate the missing quantity. So it says mass in grams of this number of moles, which is nice. Then we have that. So I put all of this over 1, like I've done for all of these problems. I hope this is not a mystery and that you've seen this kind of thing before. And that's I2. So if I have moles on top, that means I'm going to need 1 mole on the bottom of BaI2. That means that whatever my number of grams is going to go on the top of BaI2, like that. And I do that so I can cancel moles and moles like this. Ba and I, 1 and 2, times 126.9 times 137.3. There we go. What is that? 2. Let's do this just to make sure. 0.9 times 2 is 253.8. So I add that up like this to get 391.1. 391.1 grams. So I multiply that by 0.01906, and that gives me a total of 137. That doesn't seem right. Let me try that one more time. I'll actually put in the value 1.906 EE2 minus, times 391.1. That looks much better. Okay, so here I have 7.45 grams of BaI2. Okay, so that's how you do the first one. The second one is exactly the same thing except in reverse. So I always start with the stuff that I have on top, like this, number of grams, like that. My compound is NH4Cl. Okay, I'm not going to do the whole problem here for you. You should know that the number of grams that you need, though, will go on the bottom like that, and that is for 1 mole of NH4Cl. So you do the N, the H, and the Cl here. The 1, the 4, the 1. You can finish that up. Whatever you get for the number of grams then is what's going to go there. And then you simply take your 48.3 divided by whatever number you got from the molar mass of ammonium chloride. Now I want to move on and show you how to do. So there is one other calculation that comes up quite a bit. It says the number of molecules. When we have a number of something for moles, then we're of course talking about the fact that 1 mole equals 6.02 times 10 to the 23rd of whatever we're looking for. In this case, it's molecules. So sometimes it can be atoms like it is for the next one. So let's take a look as to how this works. I start off exactly the same way. I start off with my number, like that, of moles, like that. All of that is over 1. Now, here's the cool part about this. Makes no difference what that is. We don't have to do a molar mass. We don't have to figure anything else out. All I have to do is my 1 mole of CHO2, and then 1 mole equals that number of molecules. So moles still cancel with moles here, like that. And then all I do, now here's the key, I take my 0.005752, and then I divide, multiply because it's on top, by 6.02, and then I hit the EE key and 23. And what I get then is 3.46, I'm going to go an extra space here, 3.463 times 10 to the 21st molecules. So we're talking about an awful lot of molecules. And that's how you figure that out, just using this 1 mole equals 6.02 times 10 to the 23rd. Let's take a look at the next one. I'll let you answer the problem, but we'll start off though with 4.88 times 10 to the negative third moles of aluminum nitrate. This is, again, 1 mole on the bottom of aluminum nitrate, and 6.02 times 10 to the 23rd atoms. Now, we're looking for the number of oxygen atoms, so actually what we're going to find here will be the number of molecules first, and then I'm going to do one more calculation. This one's pretty easy. Here's why I say it's pretty easy. For aluminum nitrate, I have Al, N, and O. I have 1 N, 3 nitrogens, okay? So I'm taking a look at this. That's 1 N, and then 1 times 3 gives me 3 nitrogens, and the oxygen is 3 times 3, which gives me 9 oxygens. Okay, so that means that for 1 molecule of AlNO3, I get 9 atoms of oxygen. And that's my last conversion, and that's pretty simple. So here I have molecules canceling with molecules. I have moles canceling with moles, like that. So I just multiply all the way across. Okay, I tell you what, I want you to try it, make sure you do it. So 4.88, but I want to see, make sure that you're getting the right answer. So I multiply this times Avogadro's number, which is 6.02 EE23, equals, and then times 9. You should get something that looks like this. 2.64 times 10 to the 22nd atoms of oxygen. That's what you should get. All right. So anytime they're asking for a specific number of something from a molecule, you can use this conversion here, where we got the number of atoms of oxygen over the 1 molecule of whatever you have. Okay, good. I'm going to cut that there.